Question 5. This question is pretty long question. Well, it's only one part, it's only one question. It's 5 marks and it gives us a bunch of information, and that's why I feel like students will struggle with it, including myself, because it's just so much information. But you have to highlight the key details. In this case, what I'm just going to do is cross out any irrelevant information. A sample of antimony is analysed in time of flight mass spectrometer and is found to contain 2 isotopes. Okay, and what's the name of it? Antimony. Okay, after electron impact ionization, all the ions accelerate to the same kinetic energy and travel through a flight tube that is this long. Okay, and the kinetic energy is given by this. You should already know the units. And then calculate the mass of 121 sp plus ion. Calculate time taken for 123 sp plus ion, 121 sp plus ion and 123 sp plus ion to travel through the same flight tube. Avogadro's constant L is equal to 6.022 times by 10 to the power 23 moles per power minus 1. So to find out the mass of this 121 sp plus ion, this is going to be 121 times by 10 to the power minus 3 divided by Avogadro's constant, which is 6.022 times by 10 to the power 23. And like I've said in previous questions on time of flight mass spectrometry on paper 1, because I think it comes up every single paper. I don't think there's even been one paper where it hasn't came up. Might be wrong, but I feel like it has. I feel like time of flight mass spectrometry questions just come up every paper. Could be wrong, but if they give you what I was trying to say is that if they give you Avogadro's constant, you're going to have to use it 9 times out of 10. In this case, we do use it to find out the mass. So 2.009 times by 10 to the power minus 25 kg. Okay, then it says calculate time taken for 123 sp plus ion to travel through the same flight tube. Time taken. So we know velocity is distance over time. Therefore, time is equal to distance divided by velocity. Do we have the distance? Yes, we do. How long it is? 1.05 meters long. That's for both of the ions. That's the flight tube. So what do we need? Well, we need the velocity. How do we get the velocity? How do we get the velocity? Well, velocity is distance divided by time. So we can quite easily find out the velocity. But what I would... Yeah, we can quite easily find out the velocity. Distance divided by time. So let's just do that. So velocity of this ion is, this velocity is going to be distance 1.05 divided by time for the 121 sp plus ion, 5.93 times by 10 to the power minus 4. (1770) ms power minus 1. That's the velocity, okay? Now, the reason we calculate the velocity is not to calculate the time taken. And then you guys might be wondering, well, just substitute there. No, this is for a 121 sp plus ion. We need to find the time taken for 123 sp plus ion. That's going to have a different velocity. But the whole point of doing this is now we can find out the kinetic energy. Kinetic energy is just going to be a half times by the mass of the 121 sp plus ion, 2.009 times by 10 to the power minus 5, a half mv, the velocity squared. I get the kinetic energy as 3.1493 times by 10 to the power minus 19. 3.1493 times by 10 to the power minus 19 joules. The whole point of that, and then because we know here all the ions are accelerated to the same kinetic energy, so that it's going to be the same kinetic energy for the 121 sp plus ion or the 123 sp plus ion. Now we can quite easily find out, and actually not quite easy, now we can find out the velocity of the 123 sp plus ion. Velocity is equal to square root of 2k E divided by m, and the mass of the 123 sp plus ion, same thing as in the first part, it's just going to be 123 times by 10 to the power minus 3 divided by Avogadro's constant. Let's work that out. .0425 times by 10 to the power minus 25. So it's going to be square root of 2 times by kinetic energy, 3.1493 times by 10 to the power minus 19 joules divided by 2.0425 times by 10 to the power minus 25. That'll give me a velocity of 1756. Okay, and now what do we want to find? We want to find time. So time is going to be the distance, which is obviously 1.05, divided by the velocity, and this is the velocity of the 123 sp plus ion. I should probably label it in the exam, probably should label it, but for this video I'm not. Divided by 1756, and I get 5.98 times by 10 to the power minus 4 seconds. So pretty tricky question. First you find out the mass of the ion, mass in kilograms, so you need to divide 1 to 1 divided by 1000 and then divided by Avogadro's constant, and then realize that, so we want to find out the time of this ion, we need the velocity. How do we find the velocity? Well, first let's find out the velocity of the 121 sp plus ion, then we can find out the kinetic energy, and we know the kinetic energies are the same no matter if it's 121 sp plus ion or 123 sp plus ion. Find out the kinetic energy, and then we can find out the velocity of 123 sp plus ion. Velocity is square root of 2k over m. Find out the mass of the 123 sp plus ion, 123 times by 10 to the power minus 3 divided by Avogadro's constant. Substitute that in, get the velocity. Velocity is distance divided by time. Time is distance divided by velocity. Distance is 1.05. Length of flight tube can be the same for 123 sp plus ion and 121 sp plus ion, divided by 1756, and you get 5.98 times by 10 to the power minus 4 seconds. And that's the end of question 5.